Okay, so I see with this problem that I have my alpha is 0.01. That's your level of significance. And this is a hypothesis test claim. When parents use a particular method of gender selection, the proportion, so I know right now this is a hypothesis test based off of a proportion. It says the proportion of baby girls is less than 0.5. So in other words, and you can see this already answered on the left, but my proportion says that it would equal 0.5. And then you can see right here in the wording, the proportion of baby girls less than, so that would be my claim or my alternative. I don't know why it doesn't like me to do dots, would be less than 0.5. All right, and it says assume the sample data consist of X equals 78 girls and N equals 169 births. And then they say 6/13. Well, if you reduce this fraction, so this is my proportion, my P hat, if you divide the top and the bottom by 13, so all they did is they reduced the fraction for you. So that's where that number comes from. It says results in a z-score that is 1 standard deviation below 0. So we go through all these steps. So the first part, of course, we already talked about the null and alternative hypothesis. The second part, alpha, is your level of significance. What is the sampling distribution? This is a normal distribution. Definitely is not a T because we have more than 30 and we're not comparing standard deviation, so it's not the chi-squared. Is it two-tailed, left-tailed, or right-tailed? Well, that's based on looking at your alternative. So as we can see, this is a left tail. So if we drew this, basically what I'm looking at is this lower value. And it says, what is the test statistic? And then p-value. Now I'm going to show you how to do this manually, but I wouldn't do it manually. I would use my calculator, and then I'll show you how to do it with the calculator. So my z would equal my p hat, which is the 6/13, minus the p, which is 0.5, so that's my hypothesis, over the square root of p, 0.5, and then times q. Well, remember q is 1 minus p, so that would still be 0.5, and then over the sample size n. And if you put that in your calculator, the top portion becomes negative 0.384, and the bottom part becomes 0.384, and you get an answer of -1. So that's where that number came from. But the problem is looking up p-values and stuff. It's a little difficult to do. It's a lot easier if you would just use your calculator. So that's what I'm going to do. So I'm going to, using my calculator here, I'm going to go to stat, test, and students always say, well, I don't know what to use on a test. Well, remember, what they're asking you is a proportion, and it's only one proportion, z, because we said it's a normal. So I press enter. My p0 is my hypothesis, so that's 0.5. My x is 78 or 6. You could use either one. Let's say we don't reduce, 78. And then my sample size, 169. And then I want this left tail. And then finally calculate. And notice, I'm done. This is why I try to get you guys to really learn your calculator. There's my z, -1. There's my p-value, 0.1587. And now let's talk about, well, before we do that, let's say you're still wanting to do this manually. Where did that p-value come from? If I look at my table and look up -1.0, so this is under the 0, notice there's the 0.1587, okay? And so then the last part says, well, what is the area of the critical region? So basically what that's asking you is this area right here. What's that z value? Okay, with the standardized normal distribution, so that's 0. So what I'm looking for is if my alpha is 0.01. Uh-oh, I lost my table. Where'd it go? There it is. So if my alpha is 0.01, then I'm looking for the value that is closest to that. And it looks like 0.0099 would be the closest to 0.01. So it would be -2, 3, and then under 3. And that's where you see the -2.33. And then finally last, what's the area of the critical region, which we said is my alpha value. So that kind of helps you to see it manually, which isn't bad because I always say you should draw pictures to see it, but you really should get to the point where you're using your calculator to do these calculations very quickly for you.